Alrighty, in today's video, we're going to be talking about 2.4, polynomials and polynomial-like equations in one variable. All right, so essentially, we're going to be doing the same thing we did in 2.3. The only addition to the work we're going to be doing is at the beginning of it, we're going to do a substitution. So we're going to look at any polynomial and go, this looks pretty close to a quadratic if this just turned into an x. So essentially, we're going to do that. We will use the letter A, or basically any letter that is not dealing with the letters we are trying to solve for, just to make life a little bit easier. So for instance, I'm going to be on page 132 on this one. And I'm going to look at number 2. So number 2 says z minus 8 squared minus 7 times z minus 8 plus 12 equals 0. And you're asked to solve this. So yes, you could FOIL this out, distribute this, combine like terms, get it to a quadratic, and then you can use the quadratic formula to solve it, or factoring, or whatever the technique is that it wants you to do. In this case, it just simply says to solve. So I'm going to try factoring if it's possible, and then I'll default to the formula when need be. But when I look at this, I'm like, man, if this right here was just an x and this was just an x, then I would already have a quadratic. Well, when you realize that, go ahead and do that. So what we're going to do is in our first step is you want to substitute the thing that you want to be an x to make your life easier. So I'm going to substitute x for z minus 8. If this right here was just an x, I'd be good to go. So when I do that, I now get x squared minus 7x plus 12 equals 0. Now we have a simple question compared to this complicated question, where now I know a quadratic can factor easily into two binomials, where the leading term will be an x. And then I can go, all right, go into my t-chart, what multiplies to 12 and adds to -7. And hopefully at this point, you kind of got it, but it'd be 3 and 4. It multiplies to 12, but I need to add to -7, so that tells me both are going to be negative. Still multiplies to a positive 12, but now adds up to that -7. So then I get -3 and -4. So then when you set these, you get x minus 3 equals 0, x minus 4 equals 0, and so therefore you get x equals 3 and x equals 4. The only difference here is this would be where you'd be done and you'd move on. But then we have to remember that we substitute it first. So when you get x isolated, now you got to substitute what you substituted it for back in. So in this case, z minus 8 equals 3. Z minus 8 equals 4 is what the true question is. And then we would add 8 to both. So z would equal 11, add 8 to both. And so then I would see z equals 12. So now I see the actual answer is 11 and 12, not 3 and 4. But we can easily substitute it, make it something that's easier to work with. And then when we get to this point, make it easier to work with as well. So substitution can make life easier to turn something that looks complicated into something that we're more familiar with. And that's pretty much what we're doing in 2.4. So I have a range of different type of problems to deal with to kind of help you out. So let's look at another one. Let's look at number 11. Number 11 is y squared minus 5 squared plus 5 times y squared minus 5 minus 36 equals 0. Again, hopefully you're looking at this going, man, if this and this were just an x, my life would be easier. So when you realize that, just substitute that in for x. So I'm going to say x, little note here, is equal to y squared minus 5. So therefore, x squared plus 5x minus 36 equals 0. Now I have a easier problem to deal with. And so a quadratic automatically factors into two binomials where the leading term will be an x. And then I go to my t-chart. What multiplies to negative 36 and adds to 5. So in this case, I believe that would probably be 9 and 4. And I want a positive 5, so it's going to be a negative 4. So 9 times negative 4 gives me negative 36, and 9 minus 4 does give me 5. So that'd be a positive 9, negative 4. Set those equal to 0, so x plus 9 equals 0. X minus 4 equals 0, so therefore x equals negative 9 and x equals 4 would be my answer on my original part. But now I got to go substitute this back in. So really it's y squared minus 5 equals negative 9, and y squared minus 5 equals 4. All right. So then after this, I can now solve these independently. To get rid of the square, I need to isolate it. So I'm going to add 5. So I get y squared equals negative 4. To get rid of a square, I'm going to take the square root. Don't forget plus or minus. And remember, when there's a negative in the square root, you can pull out an I, and then you can really address this as what is the square root of 4, which is 2. So square root of negative 4 would give me plus or minus 2i. And then do the same thing over here. Y squared now equals 9, square root it. So y would equal plus or minus, and the square root of 9 is 3. So in this case, I get 4 answers. Plus or minus 2i, 2 imaginary answers, and plus or minus 3, which will give me 2 real answers. But it's going to want them all. It's going to want the real and imaginary, so make sure you find them all. So even though you take the square root, type in the calculator of a negative number, says undefined, it's because it's not real, but it's still part of the solution set. All righty, let's do another one. Let's look at number 12. Number 12 is x squared plus 7 squared plus 8 times x squared plus 7 plus 12 equals 0. Again, hopefully you're looking at this and going, man, if only this was an x. So here's it doesn't matter. The book will state, let this be a, since it's already an x. But if you can understand that your new x and the x that's already there is different, then you can go this route. If not, make it a different letter. Make it a Y if you want it to, or make it a capital A like the book does. It really doesn't matter because the process isn't going to change. Okay? Make it whatever you are comfortable with. So in this case, I'm going to replace it as x squared plus 8x plus 12 equals 0. And then I know, because of this note, I need to replace this x with the actual new x. So therefore, a quadratic will factor into two binomials. Leading term will be an x. D chart, I need to multiply to 12, add to 8, 2 and 6. So that would be 2 times 6 is 12, 2 plus 6 is 8, so positive 2, positive 6. So I get x plus 2 equals 0, x plus 6 equals 0. So I get x equals negative 2 and x equals negative 6. So this is the x I substituted in. So now I need to replace that x with the actual x, which is x squared plus 7 equals negative 2, and x squared plus 7 equals negative 6. So I subtract 7. So x squared equals negative 9. Take the square root. So I get plus or minus. I see a negative, so that becomes an I, and then the square root of 9 is 3. So this is plus or minus 3i. Subtract 7. That'd give me negative 13. So this would be plus or minus. Typically, they'll write the I here and then the square root of 13 since it's prime. It does look just as clean to put the I on the other side, but a lot of times yeah, a lot of times people get distracted by the I inside the radical, so they'll write it like this. Right? But there will be your answer. It would be technically 4 imaginary answers. So if you try to graph this or anything, it won't cross the x-axis or anything like that. Alrighty. So let's look at another one. Let's look at 16. 16, you're given y to the 1/2 minus 5 times y to the 1/4 plus 6 equals 0. So you look at this and you're like, all right, how do I make this become like a y squared? Um, let's see. So if I want a 1/2 and I want it to become a square, what can I substitute this in for? Hmm. Let's see. So if I let x, my goal is to get x squared out of it. I can let x be y to the 4th. So if I let this become y to the 4th, half of 4 would be squared, but am I changing the value of the expression? Don't want to change it too much. Let's backtrack a little bit in our book. That's what I'm seeing. So they had 2/3, and then they took and they substituted y thirds to make it a square. So I have a half. So if I do 1/4, oh, okay, hold on. So if I put a 4 here, I get half. I put a 4 here, I'd get 1. That's not what I want. Let's see what we can do. So if I let x equal y fourth, is that what I want, or do I want to redo this? Let's see. Let's do this way. Let's redraw this so that this is y times something. That'll give me a square here, but it'll still give me a half. So what if we say, we'll say 1/4. If we call this y to the 1/4 squared, this will give me 2 squared. All right, so there we go. So that'd be 5. And then this will just be y 1/4 to begin with, plus 6 equals 0. So if I let x equal y to the 1/4, I can then get x squared minus 5x plus 6. This will not change the value. What I was trying to do was going to change the value of the expression. All right, so then from here, I now have a nice simple quadratic that turns into two binomials where the leading term is an x. And then all I got to do is ask myself what multiplies to 6 and adds to -5. So this would be 2 and 3. Both of them have to be negative. That gives me a positive 6 and a -5. So this gives me x minus 2 equals 0. X minus 3 equals 0. So I get x equals 2 and x equals 3. So I had to do a little pre-work here to get to this point. Now I can do my substitution. So now this is y to the 1/4 equals 2 and y to the 1/4 equals 3. So to get rid of a fourth, I just need to take the fourth. Sorry, take that back. 1/4 is the fourth root, so I would just need to raise it to the 4th power. And of course, what I do to one side, I have to do the other. So if I have a 1/4, I can just raise it to a 4th power. So this is 2 to the 4th power, which is 2, 4, 8, 16. And then same concept here. Let's be 3, 9, 27, 81. So I get 16 and 81 as my final answer. So the goal is how can I rewrite it so that it has a square and so that I can also pull it out to write it like this. A good indicator is to look at the middle term, and I totally forgot that trick, that's most likely going to be, but it doesn't always work. But it's definitely a good start. All right, let's definitely do some more. Let's look at number 23. It says solve the following polynomial equations by factoring. So now we specifically do have to use factoring. I do want to note that I could have solved the ones with the quadratic formula as well, whatever you're more comfortable with. All right, so on 23, we were given y to the fourth plus 21y squared minus 100 equals 0. So in this case, again, I want this to be a square. And here's my little indicator. So I will let's make this a little note. I will let x equal y squared. And when I do that, I can kind of rewrite this as y squared squared plus 21y squared minus 100. So therefore, when I let x equal that, I can now get x squared plus 21x minus 100. Factor a quadratic into two binomials where the leading term is x, and then we got our t-chart. What multiplies the negative 100 but adds to 21. So I instantly went to 5 and 20, 4 and 25. All right, 4 and 25 multiplied to 100. I want it to be negative, so I need to make the 4 negative so that it adds up to 21. So negative 4 times 25 gives me negative 100 and adds to 21. So that's negative 4, positive 25. Set the two factors equal to 0. So I get x equals 4 and x equals negative 25. Now I can substitute, so I get y squared equals 4 and y squared equals negative 25. Take the square root. So y equals plus or minus 2. And then y equals plus or minus I, because there's a negative, and the square root of 25 is 5. There you go. All right, so let's look at number 24. So this is y cubed plus 8 equals 0. This is a sum of cubes. Is there a different way they want us to approach that, or is that the technique here? Yeah, they just did this as sum of cubes. So when you have something that is a perfect cube and a binomial, and it has a plus sign, we have a sum of cubes, which we talked about in a later section, which again was a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Remember, it's same sign, opposite sign, always positive from the original. So in this one, I would literally just, in this type of problem, I would just take the cube root of each. The cube root of y is, cube root of y cubed is y, so that'd be a y. And cube root of 8 is 2, so it'd be y plus 2. So then a squared, which is y squared, 2 times y, which is 2y, and then 2 squared, which is 4. Oh, are we solving it or just factoring it? We are solving it. All right, so then now we just take these two guys and now we have to solve it. This one's simple. Y plus 2 equals 0, so y equals negative 2. This one can't really factor this guy. When doing sum and difference of cubes, the trinomial that you're left with never factors in a quadratic. So there is not two numbers that multiply to 4 and add to negative 2. So in this case, this is where you want to use the quadratic formula. So remember, a is equal to 1, b is equal to negative 2, and c is equal to 4. So remember, the quadratic formula is negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So when I plug it in, I get negative 2 plus or minus the square root and this would be negative 2 squared minus 4 times 1 times 4, all divided by 2 times 1. Two negatives make a positive. Negative 2 squared is 4 minus, so this is 4 times 1 times 4, so that'd be 16 over 2. Keep this going, so 2 plus or minus. 4 minus 16 is negative 12 over 2. Keep it going, so 2 plus or minus. This is 3 and 4, 2 and 2. So I can pull out a I for 1, a 2, it's a group of 2, and I'm left over with a 3 divided by 2. Now I can divide each one of these into 2, so that give me 1, because 2 divided by 2 is 1, plus or minus 2I square root of 3 divided by 2, which gives me I square root of 3. So there are your three answers. So negative 2 and 1 plus or minus I square root of 3. So no need to do substitution. You just need to remember that this is a sum of cubes. Let's do another one, but with difference of cubes. So let's look at number 26. 26, again, is given as 8a cubed minus 27 equals 0. So notice it's a binomial, and it has a potential cube. So I'm going to say this could be a difference of cubes. So difference of cubes was a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Remember, it's same sign, opposite sign, always positive. So in this case, I take the cube root of each one. So the cube root of 8a cubed is 2a, because 2 times 2 times 2 gives me 8. 8a times a times a gives me a cubed minus, minus the cube root of 27, which is 3. Because 3 times 3 is 9. 9 times 3 is 27. All right, and then from here I can finish this off. So 2a squared would be applied both to the 2 and the a, so that becomes 4a squared, because the square, 2 squared is 4, and then a squared is a squared, plus 2ab. So this is going to be 2a times 3, which gives me 6a, and then b squared, which is plus 9. So these are 2 equal to 0. So 2a minus 3 equals 0. So then 2a equals 3 when I add 3, and then a equals 3 halves when I divide by 2. Super easy over here. This one, the quadratic formula is going to have to be used. So a equals 4, b equals 6, c equals 9. And then again, the quadratic formula was negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, that's going to be negative 6 plus or minus the square root of 6 squared minus 4 times 9. And then 2 times 4. So then you get negative 6 plus or minus 6 squared is 36. 4 times 4, 4 times 9 is 36. 36 plus 36, 72, so 144. 2 times 4 is 8. Negative 6 plus or minus, that'd be negative 108 over 8. And then from there, 108 would be 2 and 54, 2 and 27, 3 and 9, and then 3 and 3. So I see I got a 3 and a 2. So that would give me negative 6 plus or minus. 2 times 3 would give me 6. That's what can come out with the I because it's negative. And then I'm left over with a 3 and then 8. And then I can simplify all these by dividing by 2. So it's going to be negative 3 plus or minus 3i square root of 3 over 4. And so there's your three answers. All right, let's look at another type of problem that you'll see. Let's look at number 28. 28 is 6x cubed plus 8x squared equals 14x. Well, before you can solve anything, you always want to make sure it's set equal to 0. So I'm going to subtract the 14x over. So I get 6x cubed plus 8x squared minus 14x equals 0. Now, we don't always have to use substitution. We should be able to look at this and go, is there a greatest common factor? So in this case, I see that they're all even. So 2 can come out. And then I see that they all have an x. So 2x is my greatest common factor. Once you realize that, then divide each term by the greatest common factor to see what's left. So 6x cubed divided by 2x would give me 3x squared. 8x squared divided by 2x would give me 4x. And then negative 14x divided by 2x would give me minus 7. Now I have a nice little quadratic I can try to factor. Let's see if it goes into it evenly. Don't forget that 2x. So in this case, I would multiply to my a times c, which is 3 times negative 7, which is negative 21, and then add to my b, which in this case is 4. Two things that multiply 21, I only know 3 and 7. And if I wanted to add to a positive 4, it'd be x, there you go, minus 3 plus 7. So remember the addition to the rule, when you have a leading term that's not a 1, you have to divide by the a. So in this case, 3 divided by 3 is just 1. 7 divided by 3 does not simplify, so therefore the denominator goes to the front. So this is then 3x plus 7 equals 0. Now I can take each one of these factors and set them equal to 0. Biggest one is don't forget that greatest common factor. This is the one that usually gets left behind because there's just so much work going on here that you forget about that one. All right, so this one I would divide by 2. So x would give me 0. I would add 1, so x gives me 1. I would subtract 7, so that gives me negative 7, then divide by 3, so that gives me negative 7/3. So there will be your 3 answers there. All right, let's see if we can get it a little bit more complicated. So let's look at number 38. This one's given to us as 2x raised to the 13 over 5 minus 5x 8/5 plus 2x 3/5. So before I can try to do substitution, I need to try to get this to where there's only one x. Or sorry, where there's a constant, not just one x. So what I need to do is I'm going to look at this last term. 3/5 is smaller than 8/5 and 13/5. So in my eyes, I can at least take an x 3/5 out as my greatest common factor. And so when I do that, when I divide these two, remember when you're dividing like terms or like bases, you're subtracting the exponents. So 13/5 minus 3/5 would just give me 10/5. So I'll write it out for you, but 10/5 is just squared. This would give me 5/5, which will just be 1. And this will just give me the 2. So I'll rewrite it, but hopefully you noticed that the first go around, but if not, so this gives me 2x squared minus 5x plus 2. So I didn't have to do substitution. I just had to factor something out, and now I'm able to try to factor this out. So remember, the leading term will be an x, and I'm trying to multiply to a times c, which in this case is 4, and add to negative 5. So to get 5 from 4, I would say 1 times 4 gives me 4. If I want them negative, they both need to be negative. So negative 1 times negative 4 is a positive 4, adds up to a negative 5. So that's negative 1, negative 4. So then I have a leading term that's not a 1, so I need to divide by 2. So I get x is 3/5. Couldn't simplify, so this now becomes 2x minus 1. And then this does become x minus 2 because that did simplify. Now I can set each factor equal to 0. To get rid of a rational exponent, just raise it by its reciprocal. So I'm going to raise this by the 5/3, and I'm going to do the same thing to this one. So that right there will cancel and you'll be left with x. But 0 raised to any power is just going to be 0 in itself. Then I'm going to add 1 on this one and then divide by 2. So I get 1/2. And then this one I'm just going to add 2. So there are your 3 answers for that one. All right, let's do one more. And then I feel that you have everything you need to be successful on this homework. So let's look at number 47. So this says 3x minus 3 raised to the negative 1/3 minus 5 times 3x minus 3 raised to the negative 4/3 equals 0. If I factor this guy out, what good would that do me? Okay, so this would be positive 1/3. This would be 4/3. What if I took this and multiplied by 4? Okay, so here's my thought process here. A negative exponent means we need to bring it to the bottom. So this is technically 1 over 3x minus 3 raised to the positive 1/3 minus 5 over 3x minus 3 raised to the 4/3 equals 0. I don't like fractions, so my least common denominator in this case is actually 4/3, or this 4/3. So I'm going to multiply, because it's always going to be the biggest one, as the least common denominator. I know that terminology gets students, but this would be 3x minus 3 raised to the 4/3. I'm going to multiply it to every single term. Now, when I do that, since I'm multiplying, I would get this right here. So 1 times this, it would look like this. So 3x minus 3 4/3 over 3x minus 3 1/3 minus 5 times 3x minus 3 4/3 over 3x minus 3 4/3. Now I'm doing this just so you can see it. I would have simplified as I went. These are technically now like bases in which I would subtract. 4/3 minus 1/3 is 3/3, which is just 1. So I got 3x minus 3 raised to the first power. And then these guys would cancel. So I'm left with 3x minus 3 minus 5. So I took a complicated question and I've simplified it, realizing that these are fractions and that I can multiply the denominator, or the least common denominator, to every term. Now, luckily, this was nice because it was 0, so it worked out pretty nice. After this, I can just simplify. So 3x minus 8 equals 0. 3x add 8 now is 8, and then x equals 8/3. All right. So even though it looks pretty complicated, think about all the rules that you know and all the things that we've done throughout chapter 1 and 2 and try to get to a point where we can get to a more simpler form. All right, and that's really all that I got for today. As always, if you need more help or need help doing anything, just feel free to email me and let me know. Other than that, I'll see you in the next video. Bye for now.